Okay, so this problem comes from 2.4 where we're focusing on measures of spread. The first question asks for the range, which isn't too terribly difficult to calculate if we find the smallest number and the largest number. But again, I want to lean on our calculator skills and make sure you're able to use the technology if you need to. So again, whenever we have a list of numbers, we're going to press Stat, and then we're going to press Edit. We always will lead off with that. So I still have some numbers in here from before. I go up, get the list highlighted, press Clear. When I arrow down, the list is now clear. Come up, top L1, press Clear, come down, and the list is clear. So I'm going to take those numbers that I have here, and I'm going to put them in that list. Okay, 26.1, 32.6, and so on. So I have 10 numbers in my list. Hopefully I didn't make a typo somewhere in there. So again, I'm going to go to, so the calculator won't straight away give me the range. All right, we're going to use our one variable stats. We go to Stat, and now that we have already put our list in, we can go to Calculate. So I can calculate one variable stats. This time I don't want that frequency list. If you remember previously, we were doing a weighted mean problem. So usually that frequency list is going to be blank, or you could put the number 1 there if you get this screen. If not, then you should just get a screen that looks like this. One variable stats. You just tell the calculator second and the number 1, so the calculator knows the list that you want the stats for is in L1. So how am I going to get the range here? They don't give me the range straight away, but they tell me that the minimum number is 10 and the max is 43.2. That doesn't seem right to me. Sorry about that, confused myself. The n means there are 10 numbers. The minimum number is 26.1 and the max was 43.2. So to find the range, we're going to take 43.2 minus 26.1. Okay. And that is 17.1. That is my range. Okay, largest minus the smallest, and the calculator figures out the largest and smallest for me, and we did okay there. That means I didn't type anything in wrong. So change 43.2 to 53.8 and find the range. Well, I'm going to change the 43.2, and there's a little trick on the calculator if I haven't shown this to you yet. Second enter brings back up the last command that I just put in. So now I can conveniently slide over here and follow those directions. Change it to 53.8, no problem. And now we find the new range, 27.7. And check answer. Okay, so I want to jump to number 9. See what that looks like. So use the empirical rule. This is that 68, 95, 99.7 rule. The mean speed of a sample of vehicles along a stretch of highway is 63 miles per hour with a standard deviation of 3 miles per hour. Estimate the percent of vehicles whose speeds are between 57 and 69. So let's think about this for a minute. 57 is 6 below 63, and 69 is 6 above 63. So let me just draw a picture of this for you so you can sort of picture what's happening here. So we're following that normal distribution. So it follows that 68, 95, 99.7 rule. What they're suggesting to me here is that the mean is 63. So 63 lives in the middle of that curve that I just drew. If I go down to 57 and the standard deviation is 3, that means I went 2 standard deviations below the mean. And then if I go all the way up to 69, well, that's 2 standard deviations above. They told me the standard deviation was 3. So this is about 95%. If I were just in here from 60 to 66, that's the 68%. Okay, 95% goes from 2 below, and if we go 3, if I went all the way down to 54, let's say, all the way up to 72, that would be my 99.7%. Almost all of the data in a normal distribution will fall inside that interval. So it looks like we have our 95% interval that they gave us there. can move on. And let's take a look at number 11. Okay, so I'm going to use, I have a mean value of 1200 with a standard deviation of 300. The data set below has a bell-shaped distribution, so we're talking about the empirical rule. Determine which of the following values would be unusual. So more than 2 standard deviations from the mean. Okay, so let's try to figure out where our unusual area is going to be from the start here. We have 1200 living in the middle. And then our standard deviation is 300. So if we go down to 900, not unusual. But if we go down below 600, anything below 600 will be unusual. We can go to 1500, that's 300 above. And then another 300 puts us at 1800. So anywhere from below 600 to above 1800, we're going to go ahead and consider unusual. Okay, so above 1800, this one. Below 600, this one. Those would be my unusual values based on the empirical rule. Very unusual, more than 3 standard deviations. Well, let's come back and see where 3 standard deviations would be. Well, that would be below 300 now, and then above 2100. Right? So below 300 and above 2100, we're going to say very unusual. So that's below 300. I don't see anything above 2100. So it looks like we're okay there.